Alright. So this one here, this is called elimination. Okay, what's eliminate mean?
Get rid of.
Get rid of. Okay. So that's what we're looking for here. Okay, that's as we conduct the process that we go through, something should cancel out, get rid of, gotten rid of, whatever. Okay. So the elimination method says that addition and subtraction properties are used to add two equations together. Okay. They're usually going to be written in standard form in order to eliminate a variable within the system, and that variable is your choice. Okay. So the elimination means to cancel or get rid of. It says with addition and subtraction, the only way that values can cancel or eliminate is if they are opposite. Okay. So if I give you 5, what do you have to add to 5 so that it goes away?
Negative 5.
Okay, so if I start with 5, what do we add to that? They're called additive inverses. If you remember back to like 7th, 8th grade, and they learned the names of things or the properties of things. Two things that are opposites are additive inverses. They add up to give me 0, right? So that's kind of what we're looking for when we eliminate. If I give you 12, what's the opposite of that? Negative 12. If I give you 34, what's the opposite of that? Well, if I give you negative 5, what's the opposite of that? Positive 5. Okay. So we're just going to be looking for opposites. That says the process used here is not the only way to do this. Okay. But this is the most commonly used or commonly taught procedure in high school math classes. Okay. So the setup or the structure that I use, where if you look down there at the first example, it's got a 3x plus 2y equals 4 and 2x minus 4y equals 8. Okay. That structure of how they're set up, that's the ax plus by equals c format or standard format. That's how I'm going to do all of these with you, okay? But it doesn't matter in the long run if you're a person that kind of understands what we're doing here. As long as you have your x's on top of x's, y's on top of y's, and constants on top of constants, the equal sign on top of the equal sign, you're going to be fine with this process, okay? But I'm just going to, because of the way a lot of our questions are presented, is that they're presented in this format here. So I'm just going to work with that initially. Okay. So step 1, the way we do this, we're going to rewrite both equations so that they're in standard form. Ax plus by equals c. Usually that's already done for us. Usually that's the way it started. Okay. But if it was like 3x plus 2y equals 4, and then that maybe down here is negative 4y plus 2x equals 8, I'm going to have to fix one of those because I want my x's to be stacked on top of one another, like they are here, right? I want my y's to be stacked on top of one another, and I want my constants to be stacked on top of one another, and I want my equal sign in the same spot, okay, in both equations. So that's the first thing we're going to do. Second thing we're going to do is, I guess step 1 and step 2 are that. Step 3 says check to see if either set of coefficients, the x's or y's, are opposite. That's what we're hoping for. We're hoping that when we look at this, maybe the top one has a positive 2y and the bottom one has a negative 2y. Or the top one has a positive 3x and the bottom one has a negative 3x. Okay? Either way, either variable, doesn't matter, but that's what we're looking for. We hope that they are opposite coefficients. Okay? If they are, we're going to step 4. Step 4 says add the coefficient straight down, or the equation straight down. Okay? And when you do that, because one of the sets of coefficients are opposites, you should end up with like a 0y or a 0x. Well, 0y, you just write as 0, right? Or if I'm adding it, do I ever say like 2x plus 0? I just say 2x, right? So when you get things to cancel out, they go away, they're done, you don't write anything down for them, okay? What that's going to do is generate a one-step equation. It'll say like 5x equals 10 or 2x equals 30 or something like that, okay? And you can solve that for x. And that's what step 5 says, solve the resulting equation from step 4. Step 6 says take your solution from step 5 and substitute back into any equation throughout the problem and solve for the remaining variable. And that will give you y then. Okay. Step 7 is takes your answers x and y and write them as an ordered pair, and that is your final solution. Okay. Now this is going to generate the same type of thing that what we did last week will do. The graphing or the substitution technique, this will generate the same answers. Okay. Note down here where it's got all this bold and italicized, underlined stuff, it's pretty important. It says if step 3 is not true, What that means, step 3 was that both, or either the x's or y's had opposite coefficients. So if that's not true, you will need to multiply either one or both of the equations so that one set of opposite coefficients show up. So you are able to multiply by any number you want, positive or negative. It says we will try to make good decisions to make the upcoming steps easier. Okay? So here's what I want to kind of demonstrate this with you real quick. If I take, and actually let me close all of this and then restart it because it was messing up on my last period. So I'm going to take GeoGebra. GeoGebra is a nice tool for us to use in effort to show this algebraic relationship that I want to demonstrate for you. So I'm going to say that this number is going to go from -5 to 5, but by increments of 1. So all I'm doing here, this is the nice thing about GeoGebra, is I can change that number just by sliding that thing. Does that make sense? Okay. So now I'm going to give you I'm going to start with one of the equations. 3x, that is in that first kind of example there. 3x plus 2y equals 4. Okay? And obviously it graphs it, right? And we know how to graph that, whether we put it in, maybe we go y equals mx plus b format and we graph that, or maybe we just leave it in standard form and we use like x and y intercepts or whatever, but that is that graph. Okay? Now what I'm going to do, and hopefully this works, I'm going to take 3 times a times x plus 2 times a times y, and that's going to equal 4 times a. Okay? So what I've typed in here is the exact same thing here, but for this right here, it's going to multiply that thing by a. So right now a is 1, so it's going to make it 3. It's going to take this, and where I have 2y, it's going to multiply that amount by a, because it's 1, it's going to be 2y, and then we'll multiply this by a, so it'll be 4. So when I do that, my hopes are you realize, well, you just multiplied by 1, so you really didn't change anything. Okay? But now, as I move that a, hopefully this works. Last period it didn't. Let's see here. All right, so this is maybe the best way of doing this, because I think the way that I had it typed in, it was just putting it in its simplest version or simplest terms. So what I did here, just kind of make sure you understand this. That equation on the bottom is the same as the equation on the top, except for I just moved that 4 across the equal sign, so it had to become -4. Does that make sense? But it's pretty easy to see that these two things are the same. They're okay with that? Okay. Now I'm going to color one of those red. So this bottom one is red, okay? Now that's with a being 1, but if a goes to 2, you see how all the coefficients change, right? So this would look like 6x plus 4y equals 8, which would be twice as big as that black one, right? Everything twice as big. Or I can go 3 times as big. Everything 3 times as big. Or I can go the other direction. But what I'm hoping you see here is that red line always on top of the black line? Does that make sense? So the black one is 3x plus 2y equals 4. The red one is 9x plus 6y equals 12. But what does it mean if they graph on top of each other? They're equal. They're the same thing, right? Okay? And hopefully that makes sense to us based off what we learned so far about algebra. If I start with an equation and it's balanced, am I allowed to do anything I want to that equation as long as I do it to both sides? Did I multiply both sides here by 3? The 3x plus 2y, multiply that by 3, you get 6x, or 9x plus 6y. Take the 4 and multiply it by 3, you get 12, right? So I should still get, even though it looks visually different with numbers, I still get the same graph. And that's something to make sure that we understand. So what does that mean to me? That means no matter what I start with, no matter what equation I start with, I can multiply it by anything I want. Anything. Whole number, usually whole numbers is what we use, but you can do fractions and whatever. Okay? Because I can multiply by a fraction, that actually means I can divide. Okay? So I can either multiply these equations by anything I want or divide them by anything that I want. Okay? And I still end up with something that's the same. Does that make sense? Are we okay with that? Okay? Now here's my next question. This might not be as easy to see, but if I start with, let's say I just start with this 3x plus 2y equals 4. (3x plus 2y equals 4). Give me a number? 4? Okay, so I want to add 4 here, and I want to add 4 there. Is that okay? Is that something you're allowed to do? Yeah, because I did it to both sides, right? So let me see if I can write this way. Let's say I want to go 3x plus 2y plus a equals 4 plus a. And I'm going to keep this in the input format the way I inputted it. Okay, that's what I just typed in, right? All e plus 4 was the number we're going to add to both sides. Is the black line and the red line the same still? Okay, so this is the same demonstration of being able to multiply both sides by whatever I want to. I can actually add to both sides anything that I want to, or I can subtract. Okay, now what is important is that we added the same thing to both sides, right? We added the same thing, and in this case, it was 4, right? But think about this: so if I added 4 to the left-hand side, could I have actually added 2 times 2 to the right-hand side? Still 4, right? Okay, still the same line. But now what I added looks different, right? It's a different, 2 times 2 is a different representation than 4 is, right? But it's still the same quantity. Does that make sense? Yeah. So what I'm going to show, I'm going to tell you that this is what we're going to do here with these equations. Okay? If I start with 3x plus 2y equals 4, 3x plus 2y equals 4. What we are going to do, okay, right here I have told you a relationship about 2 expressions. I've told you 2x minus 4y is going to be referred to as the same thing as 8. Or 8 is the same thing as 2x minus 4y. Does that make sense? So this is like saying plus 4, and maybe this was the 2 times 2. These are identical, they're just different visual representations. Does that make sense? Can I add anything I want to this left-hand side? Can I add anything that I want to this left-hand side? Yes. So I'm going to add 2x minus 4y to it. Okay? Can I add this, if that's the case, can I add the same thing to the right-hand side? So now, here's the process. If I want to add visually the exact same thing, it would look like that, right? Now, we don't like to do that in this process because it doesn't generate anything useful. We like to add 8 to this side. Because isn't 2x minus 4y the same thing as 8? Does that make sense to everybody? Okay. So there's 2 steps that we're going to do here. We're going to either multiply equations by some number to change them a little bit, to change their coefficients. And once that is done correctly, we are going to add straight down. We're going to add these 2 equations to one another. And the reason why we're allowed to do that is because ultimately, when I add that bottom equation, the 2x minus 4y to the left-hand side and the 8 to the right-hand side, because I'm saying they're equal, I'm ultimately adding the same thing to both sides. And it's just what we're allowed to do with equations. Okay? So here's the idea. And I set this up into different types or cases so that when we come across them in our homework, we know, okay, this is type 1. We've done this before. This one's already set up maybe to just start doing the addition. Okay? Maybe you'll see type 2 and say, okay, now I need to adjust maybe one of these equations. Type 3 is you got to adjust both equations. So we'll see a variety of these, work with different types of kind of initial conditions that they provide us. These type 1 ones should be the ones that we want, okay, because they are the easiest. Okay, this is what we're going to do. First thing we're going to do, now I've highlighted them on my screen, obviously black and white on yours, but what you're going to look for before you start doing anything is that when you have your x's stacked, your y's stacked, and your constant stacked, that's the first thing. That's already been done for us, okay? The next thing is to look at coefficients and see if any of them relate really well. And what we remember, keep in the back of the mind, what we're trying to look for are opposites. And that's why I've got the red ones highlighted. Are those opposites? Are +5 and -5 opposites? Okay. So when I add straight down, that's what we're going to do. Because I said, as long as I'm adding the same thing to both sides. So I'm starting with this top equation, number 1 here, this first equation. And I'm going to add 6x minus 5y to both sides. But on the right-hand side, I'm going to add 6x minus 5y as -9 instead. So you add straight down. How many x's does that give you? 8. We add the coefficients, right? What's +5 plus -5? 0, right? So you get 0y, right? Do we ever write 0y plus 0y? No. Okay, they canceled out. They eliminated. They're gone. Get to my equal sign, write my equal sign. Now I want to add these straight down. What do those add to straight down? 8. Okay? So now I'm going to divide both sides by 8. And I get x to be 1. So that's the solution so far for my ordered pair. That's the x coordinate. Now how do I... Okay, I'm going to plug that back into one of my equations to solve for y. Top one's fine. So let's take this number, substitute it in the top one, so I get 2 times 1 plus 5 times y equals 17. Is that an equation with one variable now? So 2 times 1 is 2. Plus 5y equals 17. Now what?
You subtract 2 from 17.
Subtract 2. So it gives me 5y equals 15. Now what? Divide by 5. Divide by 5. Y is 3. So there's my ordered pair, 1, 3. Okay? Now, here's the thing. And I'm going to try to demonstrate this with enough examples. It does not matter. All we told us to plug back into the first one. Okay? I like that because multiplying x, which is 1, by 2 is easier than multiplying by 6, right? Now, it's just 1, so it's not a huge deal if I plugged it in this bottom one. But if I were, like, let's say x was like 12. I'd rather work with 2 times 12 than 6 times 12, right? So maybe that first one would be better. But the idea is, I'm gonna ask you questions throughout the course of the next couple of days about, what variable do you want to cancel? There's no wrong answer to that. We could have gone through this process and actually canceled the x's. Okay? Nothing wrong with it. It'll still give us the same answer. But that's not the most efficient way of doing it. Okay? When we plug back in, I'll say, well, what equation do you want to plug back into? There's no wrong answer there. Okay? There's maybe a more efficient answer, okay, but there's never a wrong answer in regards to those processes. What variable do you want to cancel, and which one do you want to substitute back into? You can do either. Okay? So here's my question. Let me just cut and paste that out real quick, and we'll do this problem again to demonstrate that it shouldn't matter which variable we cancel. If I look at that, okay, so let's say that I want to cancel the x's. What would this number here have to become so that it is opposite to 6? It has to become -6, right? What do you multiply 2 by to make it -6? A -3, right? So if I take 2 and multiply by -3, does it give me -6x? What's 5 times -3? -15y. Now 17 times -3. Just another way of doing it. So I'm just multiplying everything here by -3. So 2 times -3 is -6. 5 times -3 is -15. 17 times -3, -51. Okay? So all I did, took this equation, multiplied it by -3 in the hopes of getting things to cancel out when I add straight down. So let me do that. So this equation now, I'm going to look at the blue one, right? They're the same thing, just look different, different coefficients. It's been doing that all day. Jumps me to a completely different course. There you go. Where did I get -3? Because it was initially a 2x here, right? So remember my goal is to add straight down, right? If I add straight down, I want the x's to go away. So this one's a positive 6x, so this needs to turn into a negative 6x. So 2 times what will give me -6? 2 times -3, okay? All right, so now with these two equations, let's add straight down. What happens to your -6x and positive 6x? They cancel out. -15 plus -5. -20, right? -20y. -51 plus -9. -60. How do I solve for y here? Divide by -20, right? Does that give me y to be 3? Is that the same y that you have right there? That kind of make sense to everybody? Now, is that much longer than solving for y and x this way? Yeah, but it's fine. It works. Okay? Let's look at this one. This is the type 2 equation, okay, where we're going to have to adjust one of our equations to get something to cancel, just kind of like what we just did, okay? If I want to, and so here's the question, and we're going to do it both ways. So usually when we get down to these, maybe tomorrow, I'll say, which variable do you want to cancel out? And down here, you might say, oh, let's cancel x's. You might be an x person that says, oh, I only ever cancel x's. Or you might be a y person, I only cancel y's. You might be a person that says, I'm going to think about it and think logically about it. Which one's going to save me time? So when I look at this one, I think solving and getting the 5x or the x variable to cancel out probably makes the most sense here, right? They're not opposites though, correct? So if I started adding straight down, how many x's would you get right now? If you add it straight down, if you didn't do anything to these equations yet, you'd get 10x, wouldn't you? 5x plus 5x? Does this make sense to everybody what we're doing here? I'm going to add straight down 5x plus 5x. Well, that gives me 10x. Don't write this down. That would give me 2y. Did anything cancel out? Did anybody down here in this road down here, did anything drop out? Did any variable have a coefficient of 0? No. So we need to adjust one of these. Okay? Now, it doesn't matter which one you adjust, but this positive 5 and that positive 5 need to be opposites. How do I take a positive 5 through multiplication and make it -5? How do I take positive 5 and make it -5 through multiplication? Multiply by -1. So if I multiply 5x by -1, it becomes -5x, right? So now I changed this first term. I got to change them all. What's -1 times -1? Positive 1. What's -7 times -1? Positive 7. Okay. Huh? Yeah. So I'm going to cancel my x's, so I need to make sure the x's are opposites. Okay. Now, if you wanted to change the top one to -5x minus 3y plus 19, that would work. It'd be the same, really the same thing. Okay. But now, when I add straight down, what's 5x? A positive 5x plus a -5x. 0 x's. So those are the ones that eliminate, right? What's 3y plus 1y? 4y. -19 plus 7? -12. You owe somebody $19. You give them $7. You now owe them $12, right? Okay. Divide by 4. Y is -3. Okay. Now I'm going to plug it back in. So there's really three equations that we're dealing with here, guys. There were the two that we started with, so I'll go back to the two that we started with. Or there's the one that you changed. Does that make sense? Or that you changed something into. Chances are the one that you changed usually is going to have bigger coefficients. So that's usually one that you don't want to plug back into. There's nothing wrong with doing it. But I like to plug back into one of the original two. Okay? And it doesn't matter which one of the original two. If it's a process that stumps you, just always plug it back into the first one. Okay? Why do you want to plug it back into the bottom one? Okay, so these numbers are smaller than these numbers, right? That's fine. So I'm going to go, I want to plug this y being -3 into that bottom one. Now just be cautious on this because you're going to have minus and negative here in a moment. Yes, so yeah, 5x, and it's going to be minus, okay, and now your y is -3, right? Equals -7. If you want to put that 1 right there, you can. What's -1 times -3? If I distribute this here, positive 3, right? Okay. If I put that 1 in there, it'll look like this, and that's minus a negative, right? Well, subtracting a negative is identical to adding, right? So when we see two negatives back to back, we make it a plus sign. So 5x plus 3 equals -7. Now what do I do to solve for x? Okay, so it's going to be 5x equals be -10, right? And then what? Divide by 5. Divide by 5. X equals -2. So the ordered pair, -2 was my x. My y is -3, right? Now here's how we can check this. Go back to what we did in 6-1. Yeah, 5x plus 3y equals -19. 5x minus 1y equals -7. And then if we look at their intersection, is it -2, -3 as the intersection? Does that make sense? Okay. Now here's the thing, because I know that I was a student once before too, and I sat in class thinking, okay, this dude's showing me 3-4 days worth of work that I already know how to get the answer through by using my calculator, right? I already know how to graph it and get the answer. So everybody that writes an end of course exam or an ACT or something like that knows that we can do this by looking at a graph. Really, any equation we ever come across, we can get the answer by looking at the graph. Okay. And that's what some of this is building towards, is our logic, our understanding of, if I'm trying to solve an equation, let's look at the graph, and the intersection points of the graph tell me the answer to the equation. But they know if they're trying to test me on how to solve using substitution or using elimination, they will ask me questions about my work. Does that make sense? So you can't bypass all of this by just looking at the graph. You have to demonstrate your work. So the end of course exam will maybe ask you to go through steps and write down what you've written in your steps, show your work. Sometimes they will have a question written out that some fake student has done, and they'll ask, okay, where did they make the mistake? Okay, so they want you to be able to do the work. They're going to ask questions that judge whether you can do that work. So if I want to do the next one, I'll let you guys do the next one here. But I got you canceling out the y's, right? Okay. Now when I add straight down with those y's, do they go away? Does positive 3y plus negative 1y go away? No. So what do I have to do? Well, if I do that, then I'd be doing the same thing I did over here. Well, I want to I don't want to mess with the x's anymore. I want to multiply this bottom one by 3. So what is 3 times 5? 15. What's 3 times negative 1? Negative 3. And then 3 times negative 7 is negative 21. Now, I'm gonna hide one of these. I'm gonna hide this one, and this is the reason then why we wanted to multiply by negative 3. Remember, I had these highlighted, right? There's a 3 and a negative 1y. Multiplying by a 3 on the bottom, are those now opposites?
Yeah.
Does that make sense? And that's what we wanted to try to create. We wanted to try to create opposites so that they cancel out. Now if I add straight down, how many x's does that give me? 20 x's. No y's. Negative 19 plus negative 21 is negative 40. How do I solve for x? Divided by 20 gives me negative 2, right? Is that the same negative 2 that we had right there? Now, when you plug back in, I'm going to stop just for the sake of time, but if you're going to plug back in that negative 2 to one of those equations, we do it. Plug negative 2 in here. What's that give me if I put negative 2 right there? Negative 10. How do I get that negative 10 over here? I add it. So it'd leave me with 3y equals, what's negative 19 plus 10?
Negative 29.
Careful, negative 19 plus 10. Negative 9 though, right? So I have 3y equals negative 9. What would y be then? It'd be negative 3 again, right? It is the same question, right? So it's going to have the same answer, but we just did it a different way, right? So the hope was that we demonstrate here that when I ask you what variable do you want to cancel, the first one we showed we canceled the x's, and we got negative 2, negative 3, right? The second one we answered by canceling the y's, still got negative 2, negative 3. So it demonstrates that regardless of the answer to which variable do you want to cancel, you should still get the same answer, okay? Now my hope is that when we look at this, we logically think about it and realize it's going to be easier to solve with the x's going away. So multiplying by negative 1 is easier than multiplying by 3, right? Okay? Like, look down here at these more examples on the bottom. You can tell me anything. Which variable would make most sense to cancel here? The x's. Why? They're already opposites, right? Now, could I cancel the y's? But I had to multiply the bottom one by what to cancel the y's? Careful. It's already negative. That one's negative, that one's 5. So I multiply this whole thing by 5 on the bottom. It will give me a negative 5. Why? And they'll cancel. But that would be more work than just adding straight down because those are already opposites. Let's look here. X's or y's in that middle one. Which one would be easiest? Okay, so what are you going to how are you going to get that bottom one to change so that your yeah. What are you going to multiply so that negative 2? You're going to multiply by 2 so it goes to negative 4y, right? Ollie, what are you going to tell me?
So for the first one we just have to, you just cancel out by 2, when I say negative, like the opposite.
Say it again.
So like, how would you start that equation? Like
This one here?
the first one, first one, yeah.
Up here?
Yeah. So how would you like start that one to cancel out the x's?
So I'm just going to multiply everything by a negative 1. So that changes it to negative 5x plus 1y equals positive 7. And then the x's are going to be opposites. And I just add straight down. This one here, so that's a negative 1 and a positive 1 right there, right? So when they add straight down, they go away. Over here, this is kind of like the first one. Okay, now, Devin said multiplies bottom one by 2, right? And that's going to give me, what, 4x minus 4y equals negative 16. Is that okay? And doubling all those things isn't bad. It's not hard. So now that middle one goes away, and I can add straight down, right? Here's a question, though. What if I went through and multiplied the bottom one by a negative? And it just changes the signs. Okay? Does that cancel the x's now?
Yeah, because they're already opposite.
They're opposites now, okay? So what I always do, guys, in thinking about which ones to choose, I first go through and say, okay, are any coefficients identical? X's with x's, y's with y's. If they're identical, then I just need to multiply one of them by a negative 1. Does that make sense? And then they become opposites. My hope is that they're already identical, but yet opposites. So then I can just start adding, okay? If not, then I look at the X's and Y's and say, okay, which set is easier to get into the other? Okay, what about this one? What would you cancel first? Or what would be the easiest thing to cancel? The Y's. Why? They're already opposites, right? Come down to, and we'll do these tomorrow, but which ones there would be the easiest to cancel?
Wouldn't it be X?
Why the Y's? Okay, so one is positive, one's negative. Is it easy to change 5 into 15? Multiply by 3. Okay, now here's my question. Why? I could cancel X's, but what do you multiply 2 by? Give me a whole number, because multiplication by a whole number is easier, right? I multiply by 2 or 3 or 4 or 5. Is there a whole number I multiply 2 by to turn it into 7? No. Okay. Is there a whole number I multiply 7 by to change it into 2? No. So in order to do that, in order to make negative 2 go to 7, I'm actually going to multiply by negative 7/2. Or positive, in this case, it'd be positive 7/2 would be the best choice. When I multiply by 7/2, then we multiply by fractions. You guys don't like to multiply by fractions, right? I don't like to multiply by fractions, so I want to avoid that. But here's another thing. If I don't recognize that I can cancel the Y's here easily, and maybe I'm an X person, I only cancel X's. Can I change negative 2 into 14? Or negative 14? Can I change 7 into 14? So you could do that. You can multiply the top equation by 7 and the bottom equation by 2, and that will change it into negative 14x and positive 14x, and you can work through that way. But that's going to be more work than just canceling your Y's. So those are little things that there's no wrong answer. When I ask you cancel X or Y, no wrong answer. However, there are answers to that are going to take maybe 30 seconds, and then other ones that might take 6 minutes. We want to do the one that takes 30 seconds, right? So we'll be thoughtful before we actually start doing stuff.
So on the homework tonight, right? You have to graph.
Yes, so on tonight's homework, I think there's 13 questions. It's really not due tonight. It's going to be due to Wednesday night. Okay. There's just a collection of different types of systems. Okay, and you're going to use the elimination with all of them. Right now, what I would suggest doing is just going through the 13 and say, okay, the first one, are there any opposites, or like, is it like a positive 2x and a negative 2x? And then just do those. Does that make sense? Just do the type 1 that we went over at the beginning. And I think there's probably 3 or 4, maybe 5 in there that are like that. Then the other ones are going to be the harder ones that we'll practice again tomorrow and the next day. These are all right? Okay. But what I want you guys to understand is the reason this works, and people think like this is magic, okay, when we do stuff like this, because we don't really understand why we're doing this. But we're just adding the same thing to both sides, right? And we're allowed to do that in equations. We're allowed to add the same thing to both sides. It's just that same thing right here is 7x minus 5y, and right here it's 17. But they are said to be the same with that equal sign. So we're allowed to do these processes.